Hello guys, welcome to H2O, the A to Z of chemistry. I'm Dr. Ritu Johar, your educator for this course, General Organic Chemistry. Today we begin with lecture 10 from the course, but make sure you watch the previous ones before viewing this one. So in the last lecture, we winded up with a discussion on the nomenclature of the alkanes, the alkenes and the alkynes. Right? And I hope now you do understand that when we are naming the organic compounds according to the IUPAC nomenclature, we get all the information that is required for knowing the structure of the compound from the name of the compound itself. Right? So just writing down the name, you can just tell about the complete structure of the organic compound. So we will be moving further with the discussion on the nomenclature of organic compounds, and in this lecture we will be discussing the nomenclature of compounds with functional groups. So into the discussion on the nomenclature of compounds with functional groups, the first thing that we learn is what is a functional group. So an atom or a group of atoms which determine the characteristic properties of an organic molecule, this is called as a functional group. And when the compounds, they have same functional group, these compounds, they have similar reactions. And this is just like similar to the periodic classification that you people learn. In the periodic classification, we arrange the elements into groups and periods. The elements which were coming in the same group, they were having similar chemical properties, and that was because of the virtue of what? They had same number of valence shell electrons, right? And now we have compounds, we have organic compounds which are having similar reactions. This also, they have something in common to them. This is the presence of the same functional group. In the elements, the same number of valence electrons, and here in the organic compounds, the compounds which are having same functional group, they are undergoing similar chemical reactions. For example, CH3OH, CH3CH2OH, CH3 whole twice CHOH. All of these compounds, they have one thing in common, that is this OH group over here. So this OH group, this is called as a functional group, and because of the presence of this OH group, all these compounds, they can liberate hydrogen on reaction with sodium metal. So this is an atom or a group of atoms which determine the characteristic properties of an organic molecule, right? And because all the compounds, they having the same functional group, they undergo similar chemical reactions, we can have a classification based on the presence of this functional group. And therefore, in the presence of the functional group, this enables systemization of the organic compounds into different classes. So one class of organic compounds is going to be that which are having the same functional group. So the second class would be having another different functional group. So let us learn what are these functional groups which are present in the organic compounds. So in the IUPAC system of nomenclature, what we have learned is that the name of the organic compound, this typically consists of the prefix, the word root, the primary suffix and the secondary suffix. So first important thing that we learned was the word root. So what does the word root tell us about? It is essentially the basic unit of the name, and it tells us about the number of carbon atoms present in the longest continuous chain selected, that we call as the parent chain. So if it is a one carbon molecule, the word root we used was meth, then 2 carbon was eth, prop, bute and so on. So I hope this much is clear to you people. We have done quite a lot of nomenclature in the case of alkanes, alkenes and alkynes. Now when we were talking about the alkanes, alkenes, alkynes, what we learned is that one was a parent chain, but there were other side chains also present, which we call as the substituents, right? So there, when there were side chains, there were simple side chains, there were complex side chains, and when we were naming them, those compounds, we used a prefix for them. For example, if that was a CH3 present as a side chain, we call that as a methyl. It was a C2H5 which was present as a side chain, we call that as a ethyl group. So these were the prefixes when we use. But when we come up to the other groups that are going to be present apart from the alkyl groups, there also you have to remember that the groups like fluorine, chlorine, that is the halogens, the NO2 group. These are regarded as the side chains or the substituents, and they are indicated as a prefix before the word root. These groups, they will not be regarded as the functional groups, although these are going to impart very important characteristic properties to the organic molecules, but we will not be regarding them as the functional group. They will be side chains or substituents. Okay. So we will be studying them when we are just now going to see a list of all the functional groups that are going to be present. So we will be studying them along with them, but they will not be regarded as the functional groups according to the IUPAC nomenclature. We will be indicating them in the name as a prefix. Okay. The next thing is that the name of the organic compound, this consists of the suffix. Now the suffix, this follows the word root, and the suffix, we have the primary suffix and the secondary suffix. So what do they tell us about? The primary suffix, this gives us the nature of the carbon-carbon bonds, whether it is single bonds, double bonds and triple bonds. This we have already learned. When it is all single bonds, we use a "ane". When we have a double bond, it is a "ene", and when it is a triple bond, it is a "ine". And next, what we have not learned so far is the secondary suffix. And this secondary suffix, this gives us the information about the functional group that is going to be present, right? So this is what we have to learn, the functional groups that are going to be present in the organic molecules, and then the secondary suffixes that we use for them, right? So let us understand all this now. So now let us learn about all the functional groups that we have to study in class 11th and 12th and the corresponding class of compounds in relation to the particular functional group, right? So what we have learned so far in the nomenclature is about the alkanes, the alkenes and alkynes. When we talk about these three, please do remember they do not consist of any functional group. Okay, so the alkanes, they were all carbon-carbon single bonds, and in the nomenclature what we said was that we will be putting the word root according to the parent chain. And then behind that there is going to be a "ane" as a primary suffix. For example, we have butane, 4-carbon molecule, all carbon-carbon single bonds. Next we studied about the alkenes, the alkynes, where there is going to be a carbon-carbon double bond present in the organic molecule, a carbon-carbon triple bond present in the organic molecule. These, they are not regarded as the functional groups according to the IUPAC nomenclature. They do impart characteristic properties to the organic compounds in which they are present, but they are not considered as functional group according to the IUPAC nomenclature, although I have put them into this category. Okay, so it is just a class of compounds. Just to remember, we will be not considering them as the functional group, and this we will not be denoting in the nomenclature also as the functional group. We use a primary suffix for them. And for the functional group, what are we going to use? We are going to use the secondary suffix, right? So when we have alkenes, we will be having the word root in corresponding to the number of carbons in the parent chain, and behind that there is going to be the primary suffix "ene". For example, but2-ene, a 4-carbon molecule with a double bond at position number 2. Next we have the alkynes at a carbon-carbon triple bond. The primary suffix is going to be "ine", and for example we have but1-ine, a 4-carbon molecule with carbon-carbon triple bond at position number 1. So this is something that we have already discussed in detail, and you should not be having any difficulty in understanding this. The next we have is the arenes. Again, here you are seeing that there is no functional group. In fact, arenes are also going to be those organic compounds where there will be only carbon and hydrogen atoms in the molecules. So these are going to be aromatic hydrocarbons. And here we will be studying about benzene and the derivatives of benzene. But this is something again that we will be discussing further in the coming up lectures, not now. What we will be focusing is from this point onwards. Okay, and again this over here, what you are seeing is the class of compounds is halides. What we will be having over here are the alkyl halides. What do we mean by alkyl halides? We will be having a alkyl group, and behind that alkyl group there will be present a halogen atom. So the halogen atom in the organic compound we will be denoting in general by X letter, and this X is denoting a fluorine, chlorine, bromine or iodine atom in the organic compound. The prefix we will be using for them is halo. So you remember just now I told you that for the halides, that is fluorine, chlorine, bromine, iodine, we do not use the secondary suffix over here because these, according to the IUPAC nomenclature, they are not considered as the functional group, although again they are imparting characteristic properties to the organic compound, but according to the IUPAC nomenclature, not considered as the functional group. So we will be using not a secondary suffix for them. This is going to be vacant over here. We will be using a prefix for them. When it is going to be a fluorine atom present, we will be calling that fluoro. If it is chlorine, it is going to be chloro. Bromine is going to be bromo, and iodine is going to be ido. For example, if you see over here, this is a 4-carbon molecule. So the word root is going to be but. All carbon-carbon single bond, so this becomes butane. And when there is a bromine atom present in the molecule, we will be again numbering the parent chain. All this we will be learning in the coming up lectures in detail. Okay, so how we are going to name these compounds, where we are going to start the numbering, how we are going to name all these, we will be learning up in the coming up lectures. What here I'm trying to just emphasize is what are the functional group present and what are the prefixes, suffixes that we are using for them and the class of compounds. Okay. So here we have a bromine atom at position number 1. So we call this as 1-bromobutane. More we will be discussing later on. Okay. The next we have is the alcohols. So for the alcohols, the functional group is going to be OH. And when the OH group is present in the organic compound, the prefix that we can use is a hydroxy, and the suffix that we can use is a ol. Now, this is going to be something that is going to be the first point of confusion for you, because now I just told you that in the name of the organic compound, the functional group we are representing by the secondary suffix, and now I am giving you a prefix also for this group and I am giving you a suffix also for this group. What does this mean? Let us understand. What we will be seeing is that when this OH group is present as the functional group, what do we mean by that? We mean that this is the group that is going to impart the most important characteristic properties to that organic compound, right? So when this is the only group present, so this will be the functional group. Okay, and when this is the only group present, when this is the functional group, we will be using a secondary suffix for the OH group in the name of the compound. For example, we have over here this molecule. In this we have all carbon atoms and hydrogen atoms apart from this OH group. So this is the functional group over here, which we are denoting in the name as ol over here, and this 2 is just denoting the position of the OH group. Excuse me. So what we have is that we have a 4-carbon molecule. In this is the word root but. Then the primary suffix, because all were carbon-carbon single bonds, so we have put a AN over here. We have removed the E over here. Again, I am emphasizing that I will be giving you in detail the rules for writing the name. So just see this all over here. So this we have used a secondary suffix after the primary suffix AN and the word root. So word root, primary suffix and secondary suffix. This is the functional group over here. But there will be certain cases where you will be seeing that in the organic compound, there will not be just one group present in the organic compound. There will be more groups present also. For example, while we were discussing the unsaturated hydrocarbons, we saw that there were carbon-carbon double bonds also present. There were carbon-carbon triple bonds also present. So there we will have to decide. We will have to give a priority which out of the organic compounds which we will be having which functional group as the main group. Okay, so you are learning all the list of the functional groups, but when there are going to be 2, 3, 4 groups present, in the organic compound, only one of them will be the functional group, which we will be using a secondary suffix in the name. The rest, all of them, they will become substituents or side groups, and then we will be having to use a prefix for them. So when this is the functional group, we will be using a secondary suffix for it, that is going to be ol. When it is not the functional group, it is a side group, we will be using a prefix for it, which is hydroxy. More again, I'm emphasizing this thing again and again. You will be learning in detail about all these. This is just a brief introduction. But I did want you to understand why we are learning the prefixes for these groups and the suffixes for these groups as well. Okay. So now let us see the next list that we have. So we have the aldehydes first of all. So aldehydes, the functional group is going to be CHO group. The prefix that we will be using for this group is going to be formyl. And when this is the functional group, we will be using a secondary suffix for it, that is going to be al. For example, we have a 4-carbon molecule. We have a CHO group in this. All the rest, they are carbon-carbon single bonds. So this is going to be a bute. Behind that, the primary suffix for the alkane is going to be -ine, and then we will be having a -ul for the secondary suffix that is signifying CHO group presence. Okay, so the name of the compound is butanol. The next we have is the ketones. So the functional group is going to be a CO group. So this is a carbon bonded with a double bond to oxygen, and the rest 2 dash that you can see over here, these are where the alkyl groups will be attached over here. Okay, so this is going to be an alkyl group present over here, a alkyl group present over here. So we have the ketones. The prefix we will be using is going to be either oxo or keto, and the suffix that we will be using is going to be -one. So when we have this group over here as the functional group, the suffix is going to be -one. Right? So this is going to be when we will be learning about the polyfunctional groups presence in one organic molecule. So let us see over here one example over here. So we have, you can see over here a CO group, and with this CO group there is on one side attached one ethyl group, and on the other side there is attached one methyl group. So this is the 2 dash that we have over here, and this is the CO group. So when we have a alkyl group on this side, a alkyl group on the other side of this carbon, which is bonded to oxygen by a double bond, we call this as a ketone, and the name of this compound is going to be butane 2-one. Now how we are going to name this, please again I am saying, do not worry at all how we are going to name them. We will be learning about all this in detail. The next we have is the nitriles. The nitriles, we also call them as cyanides. And here the functional group that we have is a C triple bond N. So a carbon nitrogen group is present. The carbon and nitrogen, they have a triple bond between them, and the group prefix we use is a cyano, and when this is going to be the functional group, we will be using a nitrile for it. For example, over here this is going to be the molecule where this is again 4 carbons in the molecule. We call this as butane nitrile. Okay, next we have is the ethers. So here in ethers, the functional group is ROR, and we again do not use a suffix for it. We have only a prefix for it, and the prefix is going to be alkoxy. It is going to be alkoxy alkane that we will be having when we call a ether. For example, what you can see over here is ethoxyethane. So we have this O in the center, one alkyl group on one side, another alkyl group on the other side. So this becomes ROR. Whenever this ROR is present, we call this as an ether. And how we are naming it? One side we will be calling that as the alkane, and the other side that will be the alkoxy group. We will be learning more about this. The whole name of the compound is going to be alkoxy alkane. So this is going to be a ROR. We will be calling it as a alkoxy alkane. How we are going to name it? We will be learning more details. Do not worry. Next we have is the carboxylic acids. Now the carboxylic acids, the functional group is COOH. The group prefix that we will be using is going to be carboxy. The suffix that we will be using is going to be oic acid. For example, in this 4 carbon molecule, you are seeing the COOH group is present. So the name of the compound is butanoic acid. Next we have is the carboxylate ions. This is COO negative, and we use suffix only for this. There is no prefix over here, so it is going to be a O8. For example, you can see this molecule, this is sodium butanoate. So we will be discussing all about this in the coming up lectures. I do not have to speak it. I hope again and again we will be learning about all of them in detail. So the next class of compounds is the esters. Now, if you see the functional group for ester, this is COOR. This is somewhat similar to COOH, which we just now did, that as carboxylic acid. Yes, it is very much similar. From the carboxylic acid, if we remove the one hydrogen from here and replace it with the alkyl group, this is called as a ester. How from an acid we get an ester, that is something that we will be learning further. But now at least you can understand and appreciate that there was a COOH group in carboxylic acid, and now we have removed one hydrogen, replaced it by alkyl group. This is called as an ester. The prefix that we will be using is going to be alkoxycarbonyl. The suffix that we will be using is going to be O8. And the example here you can see, this is methyl propanoate. So the COO group in the center, there is an alkyl group on this side, an alkyl group on this side. Again, there is one more similarity. This is something which is very much similar to ethers, right? In the ethers, what you saw was that there was O in the center, one alkyl group on this side, one alkyl group on the other side. Now we have a COO group and one alkyl group this side, one alkyl group this side. How we are going to name them? Again, we will be learning in detail about all of these. Do not worry at all. How we have got this particular name, that is something we will be learning. What you have to just learn now, the class of compound, the functional group, and the prefixes and suffixes that we are using for them. Next we have is the acyl halides. Now these acyl halides, they are also carboxylic acid derivatives. The COOH group in the carboxylic acid, we had a OH in that. There was a carbon, there was a double bonded oxygen, and there was a bond with a carbon and OH group by a single bond. So what we have done over here is that we have removed a OH group from here and we have replaced it by a halogen atom. So this has become a acid halide, you can say, or a acyl halide. So we had a carboxylic acid from which we removed the OH group, replaced that by an X. Here what did we do? We replaced only the H by an R. Here we have removed a OH and replaced this by an X. And this is acyl halides. The prefix that we use is going to be halocarbonyl. The suffix we will be using, the secondary suffix, is going to be oil chloride. So here you can see this 4 carbon molecule. This is going to be butanoyl chloride. Had this been a COOH, it would have been butanoic acid. The next class of compounds is the amines. In the amines, now you can see 3 groups over here. A NH2 group, a NH group, a N. What does this mean over here is, all of these, they are amines. They will be having this separate names also. We will be learning them further. And all of these, they are separate functional groups because they will be imparting separate important characteristic properties to the organic compounds. When you are seeing this NH2 group with 1 dash, this means that there would be one carbon attached to this nitrogen. So this NH2 over here, this is a primary group that is attached over here, right? So this is going to be a primary amine. This is going to be attached to 2 carbons over here, so this is going to be a secondary amine, and this over here, this is going to be attached to 3 carbon atoms, this nitrogen, so this becomes a tertiary amine. A primary amine, a secondary amine, a tertiary amine, all of them, they are amines. So how we are going to name them, we will be again learning them later on. I do not want to confuse you much giving you so many names over here. The prefix that we will be using is going to be amino, and whereas the suffix is going to be amine. Okay, so for example over here you can see there is a NH2 group present at position number 2, so this becomes butane 2 amine. Next we have is the amides. The amides, they are also carboxylic acid derivatives. So here also, just like the acyl halides, we removed one OH group and replaced it by a halogen atom. Here what we are doing is we are removing the OH group and replacing it by either a NH2 or by a NH or by a NHR or by a NR2. Okay, so what we are doing over here is we have replaced the OH group of the acid and we have replaced it by a NH2 group, a NHR or a NR2. Right, so these are called as the amides. The prefix that we will be using is going to be carbomoyl, and the suffix for the functional group, if this is present any one of them, it is going to be amide. And the name of the compound, for example over here you can see a CONH2 group, this is going to be butanamide. The next we have is the nitro compounds. So the nitro compounds, with the start of the lecture I told you that their functional group is going to be NO2, and when this is the functional group, we are not considering it as a functional group. So it is a functional group, but it is not considered as a functional group. What I am meaning over here is that this is going to impart characteristic properties to the organic compound, but according to the IUPAC nomenclature, we do not consider this as a functional group. So NO2, we will be always having it as a side group, as a substituent, and we will be using only a prefix for it, that is going to be nitro. There is no secondary suffix for this nitro group over here. For example, this is 1-nitrobutane, where we have a NO2 group as a side group for this 4-carbon alkane. Okay, next we have is the sulfonic acids. The functional group is going to be CO3H. The prefix we will be using is sulfo. The suffix we will be using is sulfonic acid. For example, over here, this is going to be methyl sulfonic acid. So that would be all for this lecture. The next lecture we would carry on the discussion further on the nomenclature of compounds with functional groups, where we will be picking up the individual functional groups and see how we are going to name the compounds when those functional groups are present in the organic compounds. And before I end the lecture, there is one homework for you people. What you have to do is just learn the name of the class of compounds, the functional group that is present, and the secondary suffix that we use for them. For now, till we are just talking about the individual functional groups, what you will be required is to know about the secondary suffix that we use for them, right? So first, in the next lecture, do learn the functional group and the secondary suffix that we use for them. That will be very helpful for your understanding in the next lecture. So if you've liked this lecture, please do not leave before liking, and also do click on the subscribe link and also on the bell icon if you have liked the lecture, so that you get a notification the moment we put up the next lecture for you. And also, if you have any doubts, feel free, mail us at h2ochemistry@gmail.com. You can join us on our Facebook page by the same name, H2O Chemistry. You can also put your doubts in the comment section as well. Thank you and have a nice day. God bless you.